Math 3, this is actually Unit 9, Section 2 on density. Most of you have seen density before in your chemistry classes. Some of you talked about maybe knowing the density triangle. I think it goes like this, where you have the D, and then you have, I think, mass and volume like that. I'm not 100% sure. So if that's how you learned it in chemistry and want to do it with the triangle method, go for it, okay? So either way, it'll work. I'm going to go through using this formula though. One thing with density that you need to always make sure you are writing though is your units, okay? Units are very important. So please make sure you label it accordingly. Okay, so this paragraph goes through, it says the density of a substance is a measure of how much mass is packed into a certain volume of the substance. Substances with high density, like steel, have molecules that are packed together very tightly. Substances which, with a low density, like cork, have fewer molecules packed into the same amount of space. The density of a substance can be found by dividing its mass by its volume. As long as a substance is homogeneous, and homogeneous means the same, the size or shape of the sample doesn't matter. The density will always be the same. This means that a steel paper clip has the same density as a steel girder used to build a bridge. Okay, so we're going to go ahead and skip down here to our problems. So the first one, what is the density of CO gas if 0.196 grams occupies a volume of 100 milliliters? So we have our formula. Okay, it's asking us what the density is, and it's giving us these grams. Grams are your mass, so you're going to have a mass number, and then we have our volume number. So in this case, we would write this as D for density equals 0.196 grams divided by 100 milliliters. So you can type that into your calculator. Most of you, hopefully, though, you know when you're dividing by 100, though, you're actually moving your decimal 2 places to the left. So if I move that 2 places to the left, I end up with 0.00196, and that's grams per milliliter. All right, B. You have a block of wood that is 3 centimeters on each side and has a mass of 27 grams. Okay, so we have our block of wood here. I'm just gonna try to draw a picture, and it looks something kind of like this. And so it's telling you that it's 3 centimeters on each side. So it's 3 centimeters, 3 centimeters, 3 centimeters. Since density is mass divided by volume, we first have to find the volume. And so this goes into like what we've been doing. So you need to know how to find the volume of and this would be a rectangular prism, or actually it's a square or a cube, but same thing. So in terms of finding your volume, so your volume is your base area times your height. So my base area here is 3 times 3 times my height, which is 3. So we get 9 times 3, which is 27, and that is centimeters cubed for my volume. Now that we have the volume, we can use our formula for density. So density equals mass divided by volume. And so my mass on this one is 27 grams divided by my volume, which is 27 centimeters cubed. We reduce this, and these cancel out to get just 1. So it's 1 gram per centimeters cubed for my answer.
You're asking me?
Okay, that's Bronson. He's here with me while I'm taking notes today. So Bronson, you need to be quiet while I finish, okay? All right. Okay, C. A sample of copper with a mass of 89.6 grams has a density of 8.96 grams per centimeters cubed. What is the, and this was supposed to say volume, of the sample of copper? So this time we're going to have to plug things in a little bit differently. So again, we have density equals mass divided by volume. But this time we're finding the volume. So our numbers are going into different spots. So for density, I have 8.96, and that's grams per centimeters cubed, equals, we know the mass is 89.6 grams divided by our volume. So how do I eliminate fractions? Hopefully you're remembering in that in order to eliminate this fraction, to get rid of this v in the denominator, I would multiply both sides by v. Okay, so that will end up canceling that fraction out. And so now when I write this, I have 8.96 grams per centimeters cubed times my v for volume equals 89.6 grams. To get volume by itself, we then would divide both sides by 8.96 grams per centimeter cubed, both sides by 8.96 grams per centimeters cubed. These all cancel out and we get our volumes equal. We type that into our calculator and you get 10. And these reduce, the g's cancel out when we do the flipping to bring it to the top. And so it's 10 centimeters cubed, which would make sense because our volume is always cubed. All right, D. A sample of iron has a density of, so again here they're telling me it has a density here. If the mass of the rectangular shaped object is 98 grams, so now they've told me the mass, what is the volume? So same formula as above, we have our density equals mass divided by volume. And so we're gonna plug in 7.83 grams per centimeters cubed equals, our mass is 94 grams divided by our volume. So again, I want to get rid of the fraction, so I multiply both sides by v in order to eliminate the fraction. Those cancel out. So I have 7.83 grams per centimeter cubed times v equals, and then that's 94 grams. And in order to get this v by itself, we have to divide both sides by 7.83 grams per centimeter cubed. So 7.83 grams per centimeters cubed. These cancel. And we end up with our volume equaling 12 centimeters cubed, because again, our grams will cancel out. Okay. Moving to the back side of notes, E. Here we go. So again, we have a block of wood, and this time they are telling us that the density of this block of wood is 0.6 grams per centimeter cube. They're telling us that the mass is 782 grams. And then they want us to find the length, which is different. They're not saying find the volume, they're saying find the length, and they're telling us that the height is 10 and the width is 5. So when we use our formula, which is, let's see here, density equals mass divided by volume, we're gonna plug in our numbers. So I have 0.6 grams per centimeters cubed equals, in this case, my mass, they said, was 782 grams, and we're going to divide by volume. Once I have the volume, then I can plug in that information to find my length. So just as we did in the previous two examples, I'm going to eliminate this fraction by multiplying both sides by v. I do that, the v's cancel out. So that means I have 0.6 grams per centimeters cubed times v equals, and maybe we should put 0.0 or 0.6. Equals 782 grams. From there, to get the v by itself, I will divide both sides by 0.6 grams per centimeter cubed. The grams cancel out. If you type in your calculator, 782 divided by 0.6 to both sides. 782 divided by 0.6, we end up getting the volume equals 1,303.3 repeating. Okay, so this is my volume, but again, they asked me for the length. And so we know with the cube, to get the volume, it's length times width times height. So I'm gonna make a new equation now. I'm gonna write volume, so I'm gonna 1,303.3 equals 10 times W times, or my W, sorry, is 5. So I'm plugging in my 10 for my height, my 5 for my width, and then we're going to go times L for my length. We know that 10 times 5 is 50. And then in order to get the L by itself, we would end up dividing both sides by 50. And so you type in your calculator and we divide and we end up getting the length equals 26.1 centimeters. Okay, F. We have a cylinder shark tank below. Can accommodate up to 2 sharks whose maximum length will not exceed 5 feet. And so you have the cylinder. And the first question says, what is the population density of the shark tank? And round to the nearest thousands of shark per cubic meter. And so population density is normally whatever kind of population you're talking about. So population divided by, in this case, it's going to be volume. And so first of all, we need to figure out the volume in order to find our population density. I'm going to put here population density equals that. So we have the cylinder. We're going to find the volume of it. We know the volume of the cylinder is base area times height. In this case, my base area is a circle. So the area is going to be pi r squared for my base area. If my diameter is 9, in order to find the radius, we have to divide that by 2. So my radius is 4.5. So it's pi times 4.5 squared, and that takes care of my base area. And then we have here the height is 2. That's a 5. Okay, so 4.5 squared, we put that into our calculator. And then once I have 4.5 squared, I'm going to multiply that number by 2. And I get 40.5 pi meters cubed. Now, since we're wanting to find the exact meters, I'm going to go ahead and type in pi, multiply by pi. In case some of you don't have pi in your calculators that you're using, we'll just go ahead and multiply 40.5 times 3.14. And when you do that, you get 127.17 meters cubed. Oops. Okay, so we have 127.7 meters cubed. So in order to find the population density, we now have our volume here. Our population for the shark tank has how many sharks? So if you go back to the original problem up here, they said that this tank would hold 2 sharks. So that means in order to find our population density, I'm going to take 2 and divide it by 127.17. And when I do that, I get 0.016 sharks per cubic meter. Or you could have put meters cubed. Either way. Okay, the next one now says a public aquarium wants to build a tank large enough for 5 sharks. Based on the population density you found in part A, what will the volume of the tank need to be to hold the sharks? Okay, so there's more than one way of doing these problems, but for this one I kind of want to keep it as a proportion because we're going to end up working with proportions more. And so since I know this density is 2 sharks, 2 divided by 127.17 cubic meters, and I'm going to set that equal to, and we want a tank with 5 sharks, and we want to know how many cubic meters we need. And so we have this proportion here, and then we can solve to see how many sharks per cubic meters I would need. So we cross multiply, so our 2 times x is 2x equals, and we're going to go 5 times 127.17, and I get 635.85. And then we go ahead and divide both sides by 2. And I find that x equals 317.75 meters cubed. So that's how many cubic meters I would need in order to have a shark tank with 5 sharks in it. Okay, the last one here. Chicago, Illinois has an area of 227.13 square miles and a population of 2,896,016. What is the population density? And so on this one, to do your population density, you always are going to take your population. So in this case, our population is 2,896,016 divided by the area. And so my area here is 227.13. We type that into our calculator and we find that we get 12,750.5, and it's people, and the abbreviation for people is PPL, divided by square miles. People per square mile. And that's my answer. Okay, if you have any questions, feel free to ask me on Monday.